In this video, we're talking about nuclear equations and the nuclear reactions that they describe. So first of all, when we write down a nuclear equation, we write down the symbols for the elements as well as the mass number and the atomic number to the left of those symbols. So americium-241, we're going to write down the atomic number. Remember, this is the number of protons down here, and this is the protons plus the neutrons. Now, for some of the particles that we deal with, it makes it a little bit easier if instead of thinking about the atomic number as the number of protons, if you think about it as the electric charge. Because each proton has a positive 1 charge, if there are 95 protons, there are 95 positive charges. The reason where that sometimes is a little bit easier to think about it that way is when we talk about, say, electrons, beta particles. The symbol for a beta particle has a -1 on the bottom, and it doesn't have, -1 protons is kind of hard to think about, but it does have a -1 charge. So sometimes it's easier to think about it that way. But here's the deal. What makes nuclear equations really, really easy to deal with is all you have to do is to make sure that when you add up the top numbers on the left-hand side of the arrow, they always have to equal the sum of the top numbers on the right-hand side of the arrow, and the same is true for the bottom numbers. For example, here, americium-241 is undergoing alpha decay to produce an isotope of neptunium-237, neptunium. And so if we look at the top numbers on the left, there's just 241 here, 237 plus 4 on the right adds up to 241. 95 on the left for the bottom, 93 plus 2 adds up to 95 on the bottom for the right. Now, a couple of important things to remember is that it ends up when a beta particle or an electron and its antimatter particle, a positron, combine or collide, they produce 2 gamma rays, really high energy electromagnetic radiation. And that's what this is showing here. 0 plus 0 is 0, -1 plus 1 is 0. By the way, when you see a coefficient, a number in front of a symbol like this, in nuclear equations, we multiply the number in front by both the top number and the bottom number in the symbol to get the sum of the top and the bottom numbers. Now, the other thing to remember is that a beta particle and a proton, when they collide, an electron and a proton, what they do is they produce a neutron, just like this right here. A proton can be either written H11 or P11, doesn't matter. But what's happening here is this electron is combining with a proton in the nucleus of some isotope and changing that proton into a neutron. Now, when we change the number of protons, we change what element it is, right? So now we have a different element there. All right, so let's look at alpha decay or alpha emission. Here, magnesium-26 is reacting with a proton, to produce an alpha particle, and what we want to do is figure out what this other species is over here. So all we do is we make the top and bottom numbers add up on both sides of the arrow. So on the left-hand side of the arrow, 26 plus 1 is 27. That means we need 27 on the top on the right-hand side of the arrow. We already have 4 here, so we need 23 more here. We got the top number, the mass number. Doing the same thing for the bottom number, on the left, 12 plus 1 is 13, so we need 13 on the right? So 2 plus what is 13? Well, 11. Once we know what the atomic number or the bottom number is over here, we can determine what element it is by looking on the periodic table. So go ahead and look on the periodic table, look up atomic number 11, and you'll see that that's sodium. Now that we know that, we can write down the complete nuclear equation, right down here in white. Magnesium-26 plus a proton makes an alpha particle plus sodium-23. Now let's look at beta emission. So we have an isotope of potassium, potassium-40, and we know it undergoes beta emission, but we're trying to figure out what this other product is over here. So we just do the same thing. We have 40 on the top on the left. We have 0 plus x is 40 on the right. Well, x has to be 40, right? So that means we know the top, or the mass number here, is 40. Same thing for the bottom. We have 19 on the left. Now we have -1 here. So -1 plus what is equal to 19? -1 plus 20. Now that we know what the atomic number is, 20, we look on the periodic table. We see that atomic number 20 is calcium, and so we write this as calcium-40, 20 down here, and we have the complete nuclear equation right here. electron capture. So remember, when an electron combines with a proton, it makes a neutron. It changes what element is present. And so it ends up that krypton 76 can capture an electron. And when it does, we want to figure out what it makes. Well, we just add up the top numbers on the left. 0 plus 76 is 76. So we know the mass number of the product here has to be 76 also. On the left, the bottom numbers, the atomic numbers, negative 1 plus 36 is 35. So we know that the bottom number here, the atomic number, must be 35. Looking up on the periodic table, we see that atomic number 35 is bromine. And so when krypton 76 undergoes electron capture, it produces bromine 76, complete nuclear equation. Next, positron emission. So let's say we have an isotope, and we know that it undergoes positron emission, and the other product that it produces is xenon-127. What is this isotope over here? Well, we do it the same way. On the right now, the top numbers, 127 plus 0, add up to 127. So we know on the left, the mass number must be 127. The bottom number is 54, plus 1 is 55. So we know that the atomic number must be 55. Knowing the atomic number, we can see what element it is. Looking on the periodic table, we see that atomic number 55 is cesium, so we can write the complete nuclear equation. Cesium-127 undergoes positron emission to produce xenon-127 and a positron. Gamma emission. So when gamma emission is a little bit different than what we've been doing. This M right here, this stands for metastable. This is technetium-99, and it's one of the few sources of gamma rays that we know of. Metastable just means that the nucleus is excited. It's in high energy state. It's not stable. And what it does is it settles down. It settles down into a more stable state, just regular technetium-99. And what it does, though, is it gives off energy in the form of a gamma ray. So when you see a little m over here, that stands for metastable, and that tells you that what's going to happen is it's going to produce a gamma ray and the more stable isotope. Notice the mass number and the atomic number don't change here. It's just going from metastable to stable. So let's see, magnesium-23 metastable is going to produce what plus a gamma ray? Well, you just take the little m off, and it's magnesium-23 that it produces. Now let's look at alpha capture, so a nucleus capturing an alpha particle. So it ends up that americium-241 can capture an alpha particle, and it ends up that it produces 2 neutrons, and we want to figure out what else it produces with the daughter nucleus. By the way, what we call the nucleus, the isotope on the right hand side, is we call it a daughter nucleus. So if we add up the top numbers on the left, 4 plus 241, we get 245, right? So that means we need 245 on the right. Well, we have 2 neutrons here. So we have 2 plus 1 is 2. We need 243 more here. That means our mass number is 243. Now we've got that, right? All we have to do is get the bottom number, the atomic number. On the left, 2 plus 95 is 97. So we know we need 97 over here. Well, we have 0 from the neutron. So we need 97 from our daughter isotope. So now that we know what the atomic number is, we know what element it is. It ends up, if you look on the periodic table, that atomic number 97 is berkelium, Bk. And so notice, by the way, we multiplied the 2 times the 1 here, right? We multiplied these guys. So now the complete nuclear equation is an alpha particle combining with americium-241, make 2 neutrons, and berkelium-243.